morning, everyone. Welcome to the NANOG 20 dnssec workshop. There's probably no tougher audience than 30 people with laptops and internet connection. Yesterday. So, if I could ask you to please tear yourself away and give me your attention for just a few minutes, I would appreciate it. My name is Matt Larson, and I'm from Maritime Global Registry Services, formerly NANOG Solutions Services. And I'd like to welcome you here to the NANOG 20 dnssec workshop, sponsored by us, by Network Associates Lab. We have Olga Livingston, Ed Lewis, and Dan Massey, from my side, technically from my side. Just at the Maritime, we have Mike Milligan, Mark Costers, and Andy Newton. So, and then also UNC ISI. All right, so basically, just the answer is all in the wrong order. Here's a brief agenda for today's workshop. I'm already 4 minutes past time here, 4 minutes behind schedule. But I just wanted to welcome you here, and I'm going to let Oliver take over and talk about the goals of the workshop and why it is we're here. Let me give you just a brief rundown of what we're going to do for the agenda. We are going to give you a few minutes after this to try and get everything set up network-wise and name server-wise. Then we're going to have an hour and a half or so of presentations on what dnssec is, along with how to configure it by 9, and then we're going to do stuff throughout the afternoon. So I'll let Oliver talk more to the schedule and more to the goals.
For those who are not aware of it, this is what the 5th or the 6th dnssec workshop that have been held over the last year and a half or so. The first one was in Sweden last spring a year ago. We had one here in this area last year, discovered that the tools that were defined in 8 for dnssec didn't work real well. There was supposed to be one in Yokohama this summer, didn't work so well. We had a very successful workshop in Sweden beginning of last month, and there was another one in Holland. The agenda of this workshop has been to a large extent dictated by the lessons learned of these 2 European workshops that we attended. We are trying to minimize the time that is wasted in the beginning to get everything set up. So Ed sent out for you homework assessments of what to do, set up your primary, and get your secondary. I would really like everybody to have that done by the time Ed starts talking. We have a few more minutes later in the schedule to get people to catch up. We will go through the dnssec introduction, then we will go into what is involved in the dnssec how-to, and during that presentation there will be some exercises. You will generate your keys then, and then we will go on to the really important part of getting your keys registered with your registry, and yes, who got drafted to run that? We found out it was a talk. We're going to, hopefully, before lunch, I would like everybody to have signed their little dummy songs and bring them online and have the song transferred before we go to lunch, so we have that out of the way. After lunch, there's going to be the little task of, we would like you to take your own old songs, slot them into the toy songs you have here, and have it signed and bring it online. Just in case there is something in the songs you are used to work with that is going to cause problems. We want to find about it, and we can actually have something done about it, because we have here one of the main developers of ISI, Brian Wellington, and he will help you debug and figure out problems along with myself. I'll not be running a song here today, and I'll be going around helping people with problems. So if you have any problems, wait to me. After that, we will go on to the TSEC mechanisms. We would like you to exchange secrets with your secondaries and primaries. That's why you're sitting next to each other, so it's easier to exchange the secrets without yelling across the room or everybody running around. And last is the last one. It'll be fine. Your number 32. And we may have, if the people who are missing don't show up, we may have to do a little bit of adjustment of who your secondary workers. After we've done the dnssec, we have demonstrated you can use dnssec as an access control mechanism, which we think is very important. We will do an exercise that you change your key set, you add the key to it, you leave the key to it, go back to the registry, update it, see that this gets distributed. And if we have time at the end, we are going to have the parents do a key rollover. And that's where we have the most fun in Sweden, because very strange things happen there. If procedures were not followed. And then we're going to have about half an hour or more of discussions at the end of the workshop. We are trying to have this all wrapped up by 5 o'clock. I don't know what your schedule is. We can stay a little bit longer. We have the room until 7. Okay, so, and anytime we discover something during the workshop, we can have a discussion about that. Okay, so the item now is to get all the machines here up on the network, serving their zones as being secondaries for whoever they're going to be secondary for. Who claims they are ready and fully set up?
So we draw the line in the sand that if our secondary is here, it goes to whoever is here?
Yes. We will draw that line in a little bit. And just to give you a little bit more incentive, if you are not up and running 5 months, go lunch. And if you're not done by the end of lunch, bye-bye.
Okay. Yeah, I think I have it done now.
And if anybody needs help, don't hesitate.
Can you run that? You have a server section right for it.
Well, I didn't have to tell you either. I actually. Well, yeah, but still, it's hard to be
I definitely wait a little while. No way to give some people additional chance on being there.
Do you have the box?
Oh, yeah.
No reading? No. There are 2 presentations. We're only giving you the first one. After this one is done. Do you want to talk about pieces, or do you want me to do it?
I don't have to try. I could probably make something up if you just figure it out.
What we need to do is examples of the how to generate and
Easy way to
either.
Well, the easy way is EDIF equals 2, and then, DS equals 1, L equals 32, like, and then it's good.
Okay, if you want to make up like 3 or 4 slides,
You're making me slides. I remember how to use the slide mention program. It's been a while.
was that doing a PowerPoint?
I mean, I do the magic one, just doesn't really feel like lazy. So if you know this one slide that I didn't have last week. Put the videos on that up an hour. Yeah. It is?
Yeah.
Keep sucking more stuff?
Yeah.
I haven't been there in a week. Is it important? No. I got here last year.
I think it was a cultural cell phone.
That wouldn't have worked. Does narrow so far? Yeah, contact ended like the end of November. Okay.
So you're going to make up a couple slides?
No, I'm not. I'll make up one slide if you want.
Just the same size, so the synchronization is up there.
Yeah.
And this is the big one.
That wide one?
Yeah.
Okay.
Okay.
We've been able to get this here.
Yes.
I got an answer on their machine. I can't record myself. What's going on?
What next is that R? Or that RN? Okay. So the first thing look up though, you're saying just be that you're going to enter an SD version. Oh, that's the server phone. Yeah.
Mine or
Okay, that's where mine. I thought they were going to give today an introduction to NANOG, but it's not. And I'm curious, some folks here have heard of this before outside of this reference. What is the reference? You would know it. Most of you haven't heard anything about it at all, okay? So this will be a little more useful, I thought it would be. Okay, to give you some context, dnssec. DNS in general is going to go through a couple of changes in the next couple of months. Right? Actually, a big one through a couple of changes. DNS security is one of those changes to it. Dynamic update is a feature where you can change the name server on the fly. IPv6 is going to cause a significant impact to the way DNS works. They get the addresses out there, the numbers, and so on. And there are various other improvements to make it work better, Ethernet 0 and rewriting local software. dnssec itself consists of a couple different areas. The two first areas we're going to talk about in this workshop are the protection of data coming across the internet, so that I can send data from my main server out to anybody in the world, and they can follow a chain of trust back to realize that really was the data I sent. The next feature is the ability to secure queries and responses. When I talk to a name server, I'm going to be finding my response queries to the name server, not finding the name. Adding security to the query gets to the right name server and vice versa. The other two features that are going to be added here are the ability to publish certificates for PKI. Not a PKI, but publishing information out of PKI. And the other feature is to update that, put security to dynamic update. You don't need to allow people to change their name server without being authorized to do so. So make that even more useful. These slides here are a shortened version of a talk I gave for last NANOG. And the URL for the slides that I gave last time are here, and they have a little bit more detail in case you want to go back and get some more introduction. Now, the features that we're going to talk about today are the protection of internet-wide data transfer. We're after making sure that data, the DNS data, the lookup data from beginning to address, is secured across the internet at a global scale. We're also looking at protecting the transfers of your secondary information, primary to secondary, and other local transfers of queries from a resolver to a name server, or a sub-resolver to a name server. Now, right now, dnssec is defined in a couple of RFCs. RFC 2535, the first definition of DNS, the primary definition of DNSSec. There have been a number of RFCs added since then to clarify, refine, and add to that specification. Right now, it's a proposed standard. It has to go to draft standard next, then go to full standard before it's a full standard, the ICF. In other words, it's still in progress. It's gotten some level of specification, but it's not a completely finished product yet. Mine is the software which implements DNS, the most popular software which implements DNS. So we've been putting into that features of DNSSec as they become defined, as they are put in RFCs, and how when we come to the point where we can accommodate for them. Version 8.2 of March of '99 was the first time DNSSec was somewhat working in fine. There were a few things earlier. 8.2 was the first dnssec enabled one, but not everything was there yet. Version 9.0 came out a little while ago, and that's the first dnssec built in from the start, built the bottom. Right now we're trying to refine the protocol. We had a protocol already designed, but there's still some issues that pop up. There's one place that we really have a need for help is the operational experience, because we find working with this, how we handle and have keys around, how we put where, is still somewhat undefined. A lot of issues. Does the parent of a delegation want to take on more responsibility, or does they want to make it as light as possible on them and put more burden on the child, and in that case makes things a little more critical in place. Now, as far as deployment plans, most of this interestingness has been overseas. There have been probably all but one workshop I've done have been overseas. For some reason, people over there are more interested in security. In the U.S., there's been some interest in it. Certainly all of you are here because of interest. But I think there's no notice units that actually added right now.
I think, and I'm not so sure about that. I mean, verifying it here because we're familiar, I'm actually talking about the NSA.
Okay. Let me write that down now. And then Mark Hoster said.
Mark Hoster said.
Okay, because I didn't hear that the military was looking at it, forgot Bill. But again, they had, for example, some of the places in Sweden actually given a date for it. Bill?
Oh, no, it's easy.
Okay.
No, this is trying to make up their mind on what day they will start signing the bill. So, it's done.
I understand, that's further out of it.
Yes.
As far as their thing goes, on that one, it may happen, probably mid next year. Yes, I get it, fine, I'll take it.
Okay. Now, to give people some of the terminology that we're using, say, speaking of our nations or not, I think a resolve is some resolve, and that's usually within the engine. Every name server is resolved effectively. Well, generally, we're talking about resolve, and I'm talking about resolve at the very end. It could be an name server, anyway. The first service has caches, and that's what you're going to be running today. You're going to be building one of these things. And running it locally, doing all of your testing through that local machine. We have a root server, which we've set up as a state root server today. We're going to have other servers. The other servers out there, the other delegations, we'll have an NANOG server in between there too. So the root and NANOG are separate. I can get that. One thing we're going to work on here is, instead of using RR as the base of information, you get an A record. That's a resource record, an RR. And when we get to DNSSec, I can start grouping all of the records that belong together. Belonging together means they have the same owner name, they have the same classes, the same type. So if you have a host that's got 3 addresses, it has 3 A records, that set of records is the ARR set. That's the basis of work now, as opposed to each individual record. When I go through and I'm assign my zone, I'm assign the set of data at a time. Another important thing here is the difference between a zone and a server. Zones are the way DNS is split up for administrative purposes. For example, .com is a zone. .com delegates to somebody their company, like DizLab.com. Separate zones because they're administrated separately. And the security that's applied by DNSSec in a wide area is made zone by zone throughout the internet. Name servers are just giving out the data. The name servers could be more than one, or a server can serve more than one zone and maybe a zone on more than one server. So a zone will be on more than one server. So at times we talk about zone security, at times we talk about server security. For example, when I talk about security, queries and responses, that's server responsibility. One slide of cryptography. There are 2 kinds of cryptography as far as I'm concerned. Symmetric keys and asymmetric keys. Symmetric key means that I have a key, you have a key, and we cascade it back and forth. We encrypt it or hash it through that same key. So both sides are sharing the same key. That turns out to be fairly efficient from a CPU point of view. It's very easy to do that with CPU and easy operation. What's difficult is passing the secrets around. They don't grow very well. Not to even care. Everybody I know I can have one for everybody else in the world. Asymmetric keys are public-private key pairs in which I have one private key and I give everybody my public key for me. It's the same to everybody. It scales a lot better, but computationally it's more expensive. So we're trying to design the DNSSec to take advantage of each side of those. And in optimization step, we're trying to use the asymmetric keys to get to a symmetric key state save time. Okay, we're going to now some of the basics of DNSSec security extensions of what SEC stands for. This is trying to protect the data with scalability of the problem, where I want to look at www.verifone.com and get data to that.com. I don't know what my other type of key I want it to scale. There are 3 resource records that were added to this. There's the SIG record, which is going to hold the signature. There's a key record, which is going to hold the public key used to verify the signature of the data. And then there's the NXT record, which is used to prove that data that's absent doesn't exist. So if I ask for the A record for a host that I don't have online, I'll get back the NXT saying that doesn't exist, and it's there, and then something that's also signed. The key records that you're going to be looking at have these fields. Flag fields, which are a little hard to explain in a short amount of time. And for the most part, you don't have to worry about today. The protocol, an algorithm to describe the key itself, what's being used for protocol, the dnssec is 3. You see that almost all the key. The algorithm will be a 1 or a 3, depending on whether you use RSA or DSA in the workshop. And finally, the key bits are encoded in base 64 when you see them in the file. It's being trained out like this. But on the record, they're binary. SIGRR is the more interesting one when you're debugging. There's a lot more fields to it, and I'm going to put in a few of them. These 2 fields here are a validity period. And this is the time at which the SIG record becomes valid. And this is the time at which it expires. So between those 2 times it's valid and it can be accepted. One thing to watch out for, if you see a lot of data failing, make sure your system clock, not your watch, your system clock is between those numbers. Sometimes the system clock is off. We found that as being a problem in places. So that's one problem we have here is to watch out that those numbers are set correctly. Over here is the identifier of the key. What this is saying is that this zone, reverse map zone, assigns the data it's covering, and it uses a certain key, a footprint of the key. So given the owner name tells me where the key comes from, and the number in there tells me which of the keys it is, I would say pull that key down and verify this to make sure it's between the right validity period, and I should get a valid data check for the signature hold. The NXT is a lot simpler. It has the first field in it is the next name in the zone. So it's saying that from some point in the zone to the next point in the zone, there's going to be nothing in there because I know what the order of the zone is going to be. Over here, it's listed what's actually present in the zone. So if I ask for the MS record for this particular name, this will tell me, well, this thing has that, no MS record. Now, what this does to your zone is on the next 2 slides. This is showing an SOA record up here. This is sort of zone. And this is what a key record looks like. That's all boring. A couple of lines of message data. A lot of times I'll just shorthand all this out so the slide's coming out. In this slide I have, first thing on here, up on top, are 3 NS records. And that's example where I'm talking about the set of data. Those 3 NS records are going to travel together when we signed by this big record here. We're finding a whole set of records up there. Down here I have, this is all the first name of the zone. This is the first machine in the zone. And you see it has a C name and a signature over that. And there's an NXT record, which shows that the next name in the zone will be M. This one down here. So it's something in between active and M in the zone. That's what I'm trying to point out. One thing I'll point out here too is that AMP is a delegation point. It has NS records, The NSRECs are not signed in the parent, they're only in the child. So this is the father zone, it's not NSREC, it's not anybody else. So when you look through the NANOG 20 zone that we have set up there, you'll see that it has an NSREC for everybody, which is not signed. It has right now have a key which is called an null key. And that's signed, that's signed. And have an NXT record for you, and that will be signed also. All through the zone. This is a look at how dnssec works. I do the query. This is the usual form looking for data. This is the resolver. This is the name server that you might go to x2.com.
Yeah.
Yeah.
The type font is smaller than I can read. Can everyone else read that?
Look at the handout.
Can we turn the lights down a little bit?
Do you have a handout?
No.
That's why we're okay.
Okay, Professor Manning.
Yes, ma'am. We can show that having printouts is looking at. This is something we haven't had before the workshop. But this is showing, going off first to the root server, when I'll ask for the information I want, I get referred to the server which having information. And I have the query script set up to this point. And then what comes back here, in this line here, is the information I want. But it's also accompanied by the signature of that information, signed by the zone down here. And I also get that key signed by the next level up. And what I'm doing down here is I'm asking for the key to the next level up, so I can verify the signature. That gives me this key, which I now trust, which allows me to verify the signature, which gives me the data now, and that's what gets processed here and put back to the line. So what's happening now is I have a few more lookups. I have another lookup I need here because I need to get the key. I can build a chain of trust saying that the data that I'm looking for is signed by some zones, signed by other zones, is the zone that I trust. And trust, I mean, I configured that key. And what you're doing in the workshop is taking the root key, and you'll be configuring that in the name server so you'll be just trusting the root. Okay, to give you a hint of what it takes to become a secure root, and there's a whole other set of slides on this. You take a regular zone, you have to generate a key, and you can then sign the zone. So what you have to do next is take the keys that you've generated and get them to be validated by somebody, which I guess is right here. And that's a lot of work. We'll leave it down. What happens at this point, SIG records and NXT records are added to your zone before you send it out to the name server. Down here I talk about how the query works, just like on the previous slide, so that I get a lot more information from back and forth. And of course, something this short, there's a lot of variation. Okay, so those are a couple slides on the wide area as part of DNS, the SIG, the key, and the NXT. I'm going to have a couple slides on securing, talking to your name server. By design, what happens is the name servers throughout the world decide we're going to secure a name server through some very scalable approach. That means that every name server is getting the right answer and can verify everything. That lets out all of the sub-resolvers to assume they have less processing power. So we're trying to think of how do you get sub-resolvers to be secure the last hop on any information chain. So we put in something which was a little more efficient in terms of CPU usage, but doesn't scale as well. The assumption that you normally go to one name server for your information, for the most part, you can create a shared secret with that server. In particular, this really applies to secondaries. Secondaries can trust and talk to primaries to be really good set up. Now, what's introduced in this are other kinds of signatures. Now, in T-SIG and SIG0 are two ways of attaching a signature or a hash to a message. And TT is a way of going between SIG0 and T-SIG. That's part of that optimization of cryptography. The T-SIG, this one's getting a lot more attention. T-SIG is a way of adding to the bottom of the message here a called a key hash, not official signature technically, but essentially the same thing. A key hash, which when the receiver gets the message, it takes this using a secret key and make sure this message came in intact. It's not encrypted, it's just that this is intact. I get the right bits out of it. The most likely use of this is no transfer in near term, dynamic update security, and in the meantime I want to be really sure that my resolver gets the right answer for my names, or probably some kind of a multiple policy on that one. 6.0 is almost, it's basically the same thing functionally. It does the same thing, but it approaches the problem differently. 6.0 is based on having keys for a host. And public key is a host, the public key is a name server, and they do kind of a shared security element exchange. They use public keys and private keys to create a way of to generate the cache down here. So it's a little less efficient, but it scales better because the public keys are used. And T-key is something, yeah. Could you explain that just a little bit more? The 6.0 stuff? Okay, the 6.0 is, okay, how would I do a different element key exchange? Actually, it's not a different element key exchange. It's the same process. What happens is I take something, I have my private key and your public key. Okay. Okay, and I can pass data through some, I can take the hash, and I can encrypt it with my private key and encrypt it with your public key. And one after the other. It goes across. On the other side, you have my, what?
You only use your private key to generate a signature. It's just like a regular signature. It's just an automatic. It's not a set.
Okay, so that's the case. You sign with your private key and then I forgot this over time. Sorry. So is that right? I signed with my private key, the public key over the side, okay. And my
Public key verified.
Okay. Yeah, so
It's just very expensive.
yeah, it's the public key cryptography cost of funding. You're basically funding investment and funding data.
So that's the way, negotiating a way to get your secret, right?
This is what I was describing about it. T-key takes the public key that you know of, and your private key, and then comes with a shared secret and can send it across. Or actually send it across. Both sides know what it's going to be. Whenever the hash comes out, sign with one, sign with the other, just like the first process. What you buy. And what's happening here is I'm agreeing on the shared secret will be for T6 exchange. Right now, T6 is used a lot. 6.0 is not used very much at all. I don't know if it's actually good meaning. And T-key hasn't really been used a lot because 6.0 really hasn't gotten into place yet.
Actually, I have a question for the nominal folks here.
That would be it.
What is that? Is 6.0 ever going to be? 6.0 is currently partially implemented in the server, and there are no clients that use it. At some point, the clients will probably be able to use it. That's not too hard. The partially implemented in the server means that the server will currently handle a 6.0 side message if the key that generated it is on the server. But the server will not currently go out and attempt to find the key. Which means that if you want to use 6.0 for a dynamic update for zone transfer, you just need to make sure that the key is in the zone that you're talking, or that it's in the zone that you're updating and transferring, and then the server will have it, it will work fine. I'm not sure if by 9.1 will have 6.0 support in any of the tools, but if I can find some time, it shouldn't take too long. So hopefully it will. Answer your question.
Okay. Okay, let's start wrapping up the introduction. What will dnssec do to the name server? It's going to change things. Data now comes and goes from the zone. Right now, if you put a zone up there and let it sit forever, it'll never really go away. The primary master will always have that data revalid and so on. Signatures are going to have that validity period, and that means they go away. When they go away, the zone has to change. So now, you have to increment if you don't replace them. So now we have to actually pay attention to our zone data more frequently. The biggest impact, though, is going to be in how you deal with your delegation. Now, instead of just paying every 3 years for your name in .com or whatever, you're going to have some way of making sure that your key is constantly updated, constantly validated by the parent, covered by the parent signature. So if your key has to be changed, your zone has to be, or the key has to be changed, or the parent has to be changed, you're going to have to be some more information going back and forth. And so you're going to be more involved with talking to the delegator. And when we get into managing keys and the photography stuff, you have some issues about who actually owns the secret. We have something to learn about that. And there's going to be a need for more resources. So this is clarifying thing about delegation. When we validated zones key, one thing that's important to know about that was that if I give you, if you're a registry and I give you my keys to my zone, and you go ahead and sign them, you have to be sure that I'm the right person to send keys. You have to make sure that I'm the right person sending keys in. And then validate these keys correctly. There'll be a lot of work on doing that. And we're working on automating this, mostly because Mark and his group really need to automate it. Thank you. We talked about offline signing complexity in DNSSec. That refers to the separation of your DNS servers and the internet that you're serving, or the intranet, or whatever you're serving, from where you actually do the work with your private key. Ideally, the private keys used to sign the zone will stay here. Only the data and signatures from the public key ever get outside of this area. The reason for that is simply that if someone hacks in and breaks to any machine, you don't want them to find your private key. That would be a very bad thing. It's really prevalent if you're like .com, your private key is taken. That could be, every other key in the internet can then be changed. Every other key in the .com internet can be changed. So we're going to keep it out there. Although dynamic update is complicated because I have to have some data added here and I have to have private key up there, and so on. The performance consumption is an increase in about everything used. And verified keys means that the more queries, the more expensive to send out on the internet. And this is the next slide, or this place to pick up more information. These are the RFCs, 2535, the next couple define the spec, the base spec. The other ones down here are the refinements added since then. There are two working groups in the ITF, DNS extension and DNS operations. They're looking at different aspects of DNSSec. And their charters are here. These are some of the internet traffic that refer to DNSSec. You can find just about all this information off the charter page, except for I think 2535 is not there. That came out of a previous working group.
Simple secure update, and the last one on there are, as possible, the hurdles are just waiting for RFC publication. So there will be RFCs whenever the RFC editor bugs Brian.
Hasn't happened yet.
Okay.
And the other sets of slides here, NLNet is one of the actors in Europe looking at this. They're going to follow the most actual work with finding zones outside the country. They're probably the ones actually trying to run software the most than anybody I know. Because of slides here, they've got a lot of links other places. And down here is Find 9, place to get Find 9, which does DNSSec. These are all recently checked, so they should still work. That's the end of the first question.
Okay. We'll take a 5-minute break. Anybody wants to do a bio break? Who has not finished setting themselves up? No.
There's one here, it's one of my colleagues.
Good luck.
This is going to come through steps of actually using the tools we have in front of you. The agenda I have here, the first thing I talk about are the executables that are in the blind release. That's going to be used for DNS security. I'm going to talk about using those programs, getting beyond the .-h printout. Talking about controlling most basic keys, finding your zone, getting keys, validated, and so on. Following that with what goes on in the configuration file to make things work. To get configure the root key, for example, the AXFR, G-SIG, setup. And then talk about a couple other items like the validator, which is going to be doing all of the work, judging the security of an answer. Going through changing the data. Once you have everything set up, making a change 2 weeks later is a little more involved than it is currently. And we'll talk about some of those making changes in that. Now, there are 5 executables that are more or less involved. First of all, main is involved. That has the core dnssec in it. Where you see that is for being a dnssec application that you have to configure it correctly to add security, not turn it on. And so we're going to talk at the end. There are 4 dnssec-something executables, and how do dnssec work? dnssec keygen is used to generate keys of any kind that we need. dnssec signed zone will take a master file that you're used to using now and running that through the signer and generating a .structure file, so it has all the things added to that. Make key set is used to take the keys that you've generated for your zone, and you want to use them in one time, and package them together in a file that is what the parent will take. And you pass it to your parent to send that off to our parent, whether it's through the web or through some other interface that's going to be developed. And signed key set is used as a parent to take that key set handed to it, generate a signed key set, sent back to the child. And the result of this is what the child will include in their zone, in their key. Now, the 4 dnssec executables have its own feature that if you put -h on the command line, you get a usage statement. And this is what I want to show the usage statements for the first quarter, the small quarter. dnssec keygen has syntaxes the executable options and who you want to have own the key, your zone name essentially. The options are broken into required options and optional options. The alcohol options and the options definition of an option. Algorithm lets you select what crypto algorithm you want to use. RSA and DSA are the 2 primary ones. Those are the asymmetric algorithms that are in mind. ASAC MD5 is the way to generate key secure secret keys. DSA or VH 50,000 keys are used for C keys. And RSA MD5 is actually another way of saying RSA. That may change as well. That won't change in the future, but there may be some RSA something in the future. Down key size of bits is the next thing that has to be specified. And what I have here is a range of bits that bit size you can use. GSA is 512.1024 and divisible by 64, so that means there. The name type, we're going to use both our zone keys. The zone key that's finding us on, yeah.
Don't use RSA with a key at work in about 2020 because there was a weird bug in the crypto library that caused it to crash.
Okay, so
I don't know.
equivalent of 48, put like that 2020 or something.
Yeah.
Okay, and the only other key is in here, that normally you will use the top 3 A, B, and N as the options. Now here are other options which are used mostly for specing the key, or changing the key from the default value. So we're talking about the -R a little bit. or dash line. Sign zone, this takes zone file I want it to sign, and the keys I want to sign it with. I'll take it default away. What I have in here is I can change the validity period in the this one date format, year, month, date, hour, minute, second. And I'm assuming that's UTC, Brian? Yeah. Okay. UTC, not local time. Let's see. Cycle period allows me to say if I have a signed file input to this, and then signatures are in there, the signatures are expired when I run the signer. I'm also going to get rid of those signatures. If the signatures are not going to expire for another year or two, but they're really bad thing, they have very long time, as long as it's a signature, the signer will just reuse that signature, won't change that. What this tells you is that, say if the signature is going to expire in the next 10 days, pretend it's expired now, get rid of it, and then re-sign what's in there. So, this is used for when I re-sign the zone down the line, and I have specific signatures that I want to have expire before their time, and they won't run out. The reason I even do that is if I'm signing zones every Monday, and I have signatures coming in that are going to expire on Thursday, if I don't sign them on Monday, come Thursday, the signature drops out, and I have Friday, Saturday, Sunday without a signature. So on Monday, I say, well, if it's going to expire between now and next Monday, drop it down to the signature, and it'll go away. For rope level, I think the rope level 3 is what I give you all the time as signature time. It shows what steps are together and probably looking to add. Minus O is what you can use when your zone file is not the same name as your zone. For example, what I've done a lot is I have a zone file appended with the SOA serial number so I can keep track of all the zone data I've had over some time. So what happens there is my zone file will be my zone dot, that's the information I add to each file. But my zone would be the name of my zone. If that's my zone is there, I assume the zone file is the same as zone. And again, my R will get to it a little bit. Specifying the key. When you generate keys, they come out with a capital K and a name identifier for the key. When you come here to specify the key, you don't have to worry about which of those files is needed. You just use the capital K, complete this name, get rid of the trailing dot. Make key set takes the key that you have here, should be one or more of those K something per zone. And they'll bunch those together. They'll take all of those and create a file which has all the key files in one of it, plus the signatures of all the keys over the entire set of keys. And here the important thing usually is to run keep a TTL. Make sure that you have a TTL set to whatever it is you want. And I recommend today TTLs and 1 to 3 fairly short for data time down fairly quickly to each expression. And the last of the 4 executables is the signed key set. This takes the keys that come out of the previous executable, or the file of that previous executable, and signs them with the keys over here. And ideally, so most likely that would be, for example, sysap.com's.keyset, signed by kcom.whatever keys are being used for com. This is something that is important. This is the homework.
Why don't we let people generate keys now before we...
Well, let me go through some more generate keys. This is an important thing to have in a workshop. This shows that the validator, which is doing the checking, is actually working. If you have your name server and your name server is running and you don't see the logging, something else is really wrong. If things are right, we'll start seeing the effect of dnssec in the file specified there. So make sure you have, this is the example configuration file that was sent out. The homework assignment. And sample zone, which one thing that's significant there. And we're going to go through the idea, go through finding a zone. And this gives you one more list of what we're going to do. We're going to go through generating keys, finding the zone, creating a key set file, getting the keys to be validated, combining all the information together, and also talk about finding your delegations as we go through the workshop, and then configuring and loading the name server. Okay, for making keys, we're going to start out with this. We're going to start with just one pair of keys. And through the workshop, through this slide, I'm going to go through a few other types of keys, once we one at a time. And the other issue that I'll cover now is going to get to everything like this. Okay, so now this is the first slide where you can start generating keys. Try to generate keys. This is an example where I'm running on a previous data machine which had a problem with dead random. And I'm running key generation here, minus algorithm RSA, 512 bits, and in zone key. And then this was the zone I was doing when I did the slide set. And keys to that zone there.
So if you want to control this RSA key?
It wouldn't hurt. This is a bad way, by the way. It wouldn't hurt. In other words, yes, unless you want something else. Fine with me. This is on Linux. This is show you a Linux, not the Linux that you got previously or whatever, but this is what the output would be if you don't have a problem with that random. But this part kind of weird. Every key that generates in this has the same first digit of the footprint, which shouldn't happen. I don't know why.
And the name of the key should be the name of your cell. .920.
How are we doing on key generation? People, getting keys, getting a lot of extra time on the keyboard, they can read it over there. Yeah, so, random question, since we're playing with dnssec on line 8, really the first time I'm telling you to impose dnssec on line 9. Is there a reason why arbitrary change information with mainline parameters? I guess because they're written from scratch. Well, what's the question? Is there a reason, given that if people already had dnssec working, however, bolted on or whatever with line 8, is there a reason why the mainline parameters were changed?
About 99% of the people who tried to use the dnssec signing for the zone signing program in line 8 complained that it was impossible to use. And I think the other 1% of the people weren't there. And also, the key generator was changed because, I don't remember why, I think it was just changed for consistency, and the other two programs are new. So, the new syntax is in both cases easier to use. And, I don't know, that's pretty much right.
One of the problems is about parent files didn't work. So that was a fundamental one change. So that's what my team said. Make sure that we're having 3 and 1 files. This pretty much works with the old data.
Yes.
Any other questions about all this? Waiting over here. Remember, the minus R option is one I kept saying coming up. Something that you might have problems with is getting randomness. Not every system has random data. I have a Solaris box that doesn't have data range.
Your data set passed your Solaris.
Okay, I have a box.
But I'm telling you, this is on my time with your guest.
Okay, like I said, I have. I didn't say.
I'm just giving you information. Thank you.
I'm aware of that. That's why I all married stuff.
Business phrase for a few months.
Come on. In the event you happen to have a machine unpatched, doesn't have random data, you may have to supply random data to the program. And minus R allows you to specify a file which should have really random data. Like that, some places dead random doesn't give out the right, it didn't set up this right. You can get data from dead random, put it in the file, and apply that to the program. One thing to be careful of is you want to make sure that the randomness that you have in that file is good, because bad randomness gives you bad results in designing and generating keys. Now, randomness is really important when you generate any key, RSA or DSA, or HD, magnetic 5. It's also important whenever you sign with DSA, but not when you sign with R.
That's right.
Okay, is everybody satisfied with getting keys? Okay. Next step here is to take the keys you just generated and find the zones. And I have a command up here. The commands I put in here initially were very minimal. But I want to point out down here I added a -v3 to the command. So if a dnssec find zone, the name of your zone, or your zone file up there, minus O if you have a different from that. The ER is different from the zone file. And then the key that you want to sign with. And you can actually get rid of the .c if you want. It doesn't matter. And if you want to see more output, put -v3 and it'll go to all of the records you have.
You have a situation where file name is not exactly the same as the right, so it's no name. -O is the actual no tooling real zone name as opposed to whatever you call the file name.
Right.
Zone file.
Yeah. One of the really common errors at this point is when you hit the, when you start finding the zone and it says zone data is out of zone. That means that it doesn't have, you haven't named the origin right. For example, if your zone file name is the same as the zone name, you didn't tell it that it's everything's out of the zone. Saying that doesn't mean you get out of the zone.
And that's quite confusing because most of the time you don't name their own file the same as.
Is there a requirement down there? No.
You put the name of the file in the command line.
Right. But I don't have to reply.
I think I've tried it.
If there's a dollar origin is like the first line of the file or the first 5 lines, is there a good reason why we don't need to specify the command line?
It's not the program, it's the underlying library required when you load a database that it needs to have the origin.
Okay, fair enough.
No.
We're trying to optimize things that work better.
Yeah, it would be nice if there was a way to do that, but there isn't really.
One thing to point out here is that if it looks like it's signing things correctly and your zone file isn't named your zone, it says signing something, domain name / type, the V3. Make sure that what's printed out there is, that's the name of the domain name it's signing, not, it shouldn't be the file name. It can be confusing. I mean, make sure it's signing the right stuff. If your name was zone.tv, it says something like ns1.zone.tv /ns record. You don't want that. You want to say ns1.zone/ns.
Other than these 3 are the right levels there.
Yes, well, that's the file.
The expiration time change.
I went from 3 to 5, and it looked like at what point is this?
I don't know.
Everything for both of them.
I don't know if there's really the verbal flow. I don't think we have to define
A number means anything. Is there something the equivalent of the -SD option to NSI or inclination?
I don't think so.
Yeah, but it was, that was very useful in terms of being able to run a test case and say, yes, this thing did, keep the correct number of old signatures and still valid, and the correct number of new ones. Well, on the option, very useful.
Yeah, I can add something like that. It shouldn't be too hard. I mean, it probably wouldn't be exactly the same as the binding format. And the format is not. It might not be able to keep exactly the same as the binding format, but it probably wouldn't be that hard to add something.
So, my question was basically in terms of, right now, I could use the proposal to say, yes, it really is doing something. Before I could actually, make a change and verify that I got the exact correct number of.
Okay, I'll look into adding that before 9.1.
That'd be neat.
Okay.
That's mail to Brian.
I'm writing it down. If this works out with 2 days, I would do it today or tomorrow.
One thing that
You're running, you're a little bit.
When you talk about funding, you should have here. Yeah. Obviously, like you said, there's other
if you forget to put the key on the sign command, what ends up happening is you get a sign sold with no signatures, but the NXT records get added.
If you do what?
If you forget to put the key on the command line.
In future versions of the new reporting, you'll print a message like, there are no keys here.
Brian, is that known in the notebook?
Yeah, so they will.
It's a feature. It's a great tire.
It's a good fix, but I don't know more than the fix will show up.
If you had keys in there, it's a false key you had in there.
Yeah, if you don't specify any keys in this amendment, it just goes through all the keys in the node file. If there are no keys in the node file, then it just goes through the keys.
This is an example of where we're using the tools here and helping us build it better because there were assumptions built in the code which are turning out not to be true. Like, we don't put the keys in the file first, we'll find it now.
What?
We no longer have the assumption that the keys are added to the zone file and done later after the rest of the workshop.
Yes, that's right. If there's a key statement on the Apex, then all the keys and non-set are used. So it's a private key available. In this case, there are most people, except for Mr. Registry, have no keys in there. So the XXC is no signature.
Yes.
What I want to put out in this slide here is that these records here, the red ones here are the first name in the zone, the black are the first. They're not exactly in any specific order. The SOA record does come third still, followed by the signature, the NS signature, and so on. When we get down here, the first thing is the host is actually the signature for the record. Print it up here, and the two records I had for the same in the original file are down below. So the output of line line signer is not necessarily in the order you think that would be to be restored. The reason for that is line line is needs to be stored.
LBD bind 9.1 signer, by the way.
Okay, now what is
In 9.1 it will be footage correctly.
okay? My last slide here is about 9.1, and it will be changed. I'm going to talk about 9.0. This is the key thing for the workshop, and we have time to talk about it, but then we'll how are people getting success here? People are getting success here.
So everybody signed us on by now?
Okay. Anyone having any?
It'll fail.
No TTL. No TTL.
Do you have a TTL statement?
No.
Come on in.
It wasn't in the example information from the home.
Well, that's the guideline, Bill. The guideline helps you build upon it.
It's line 9 release line, but ultimately it says line 9 will no longer, no, there is a TTL in here. There is a TTL in there. Fail load, their DNS message was no TTL.
Okay, for John. That's your size file. Next up, what we want to do next is we want to validate the keys that you've made. So that they, chain of trust helps fill off. The next few slides will talk about that. But first, I'm going to talk about the reason for having this is that if you gave this information and you signed it and showed me here's my public key, I don't necessarily believe that you're the right person. I can impersonate someone else. Hold the key is in their name, data, sign it myself, and say, well, I'm so-and-so, I'm not. Here's the data, here's the signature. I have a private key, not that person, so you may just believe that blindly from photography. We have to be able to say that, here's the key that I have, and here's proof that I am who I am from someone in authority, someone above me in the tree. And what we're doing at DNS right now is following the hierarchy. So your zone will be signed by the next zone up, and so on to the root, because everyone will be somehow configured to trust the root and have the routine correctly. Now, when I talk about this, there's a situation in which, when you're signing your zone, if the parent is signed, it's pretty easy. The parent signs your key. We can work on that. If your parent is not signed, if you're working for some department at some school, school has not gone and signed it, school zone, school like you, you're going to have to figure out some other way of making your zone look secure because whoever you want to have see you is secure. So we have a case where the parent didn't sign. This picture here, these two pictures, this one and the next one, will show that what's happening. I'm talking about the NANOG 20. And this picture here, NANOG 20 has a signed root. This root file is signed. And I have this one key up here configured in all the resolves. And I'm sure some other keys you're going to talk about later too, is that I have multiple keys up here, key 1 and key 2. Key 2 is what I'm using to sign everything at this level here. EDU key is signed by key 2, the NANOG 20 is signed by key 2, and so on. But up on top, key 2 is signed by key 1, and key 1 people have. It's kind of a cross. I'm verifying myself with my own key. And the root will probably work out. We're looking more and more at doing it operationally. I think today we didn't do that. We took it straight down the tree. And then I'm putting, I have that signed there. So for example, when I get the A record for any server in this zone here, it's signed by this key, signed by a signature by 4, to verify it's signed by 2, and so on, to key 1. That's the case that we're licensing. In the interim, if the root zone, for example, or something above me is not signed, I can do the same thing where I have multiple keys here, use key 2 everywhere, sign everything. So that when the chain of trust goes to key 2, it's signed by key 1, and key 1 is the one I put out. Like,
So the resolving server has to keep the whole chain, has to trace the whole chain back?
yeah. Yeah. And this is where we think that dnssec, definition of public key, does this on a naming server, and here's where it responds to your client. It doesn't want to do all of that work. That's how that plays in.
As a result, it doesn't have any trust key, which doesn't even go to that.
No, but if we have a shared secret, maybe with the trust key going forward. In your laptop, you don't have names that are running. You can tell it to just trust some secret of the full name server that you use. That name server there may do all the computation.
Let's say somebody from Herald.com doesn't have Herald.com doesn't have, so it doesn't implement dnssec.
Right.
Goes out and queries the domain that does have it, then this doesn't disappear.
Herald.com should ignore the data. It should just ignore it.
It doesn't ignore the extra data, but we'll still get the correct result.
Yes. Why I suggest that way is I have a previous D machine that are not checking security, and when they do a lookup to one of my zones which is signed, it says, caution, looking at A record for this came up with record of type 6. The A record is there. But some operators will say that I see signature records and I don't like them. There was a case where SSH finds somewhere that I won't use because there's not an A record here, it's a 6 record. But for the most part, yeah, the data comes in, hopefully the resolve the client can actually pull out the right information. Okay, this slide here talks about the previous 2 slides. Key 1 and key 2, you know I moved them, so that this plot is all the previous slide. Key 1 I'm going to spread out to everybody, key 2 I'm going to use to sign all of the data in the top zone. And sign key 2, key 1 and key 2 together as a set are signed by key 1 and then also signed by key 2. We're going to have, so there's 4 things all there. What's happening, one problem here is the more I use key 1, the more chance someone has of guessing it. So we're trying to limit it to key 1, so harder to guess what the private key is. Key 2 gets thrown away all the time, so I don't care if someone guesses that. If I guess within 2 weeks, I'll use it so we can throw it away. Down here, when we tried this in one of the workshops a while ago, we had some problems with it. It's been changed, but I haven't verified that it works, so we didn't put that in here. And if this doesn't work now, it's something. And maybe it's just not released yet. Well, I don't know. Okay, first thing I need to do in order to get my keys validated, I have to run the key set. And when I'm making the key set, there are two pieces of information that have to be added to a key before I can validate it. And those two pieces of information are the TTL that I want to use in my zone. If you look at keygen, the output of that, which is on this slide, the keygen puts out the key, and it has the owner name, it has some flags, it has the other information that belongs to the RR, but it does not have the TTL. It also doesn't have the period of time in which I want the key to be used. Because I could say I'm going to use the key every week. So I'm going to generate all of my keys in January, all 52 keys for the year, right away. So I'm going to have a key per week. So when I generate the keys, it itself doesn't know it's only good for 1 week. So now if I go to the parent and said, I want you to sign these keys for me, I've got to tell the parent to use this TTL and also use this period of time in the signature validity area. The TTL, we've got to be a problem with that originally because my TTL was higher than my parent's TTL. They assumed their TTL. We had problems with records that were too short in time for the zone, so we had to have the child tell the parent what to do. And the validity period is sadly happy because no one else can get that. So this command here takes the keys that I have here. This would be your key again, K something.nanog plus 00, and this depends on your particular key. It makes a file which is called .tset. Whatever your zone name is .tset. With a K is the zone name .tset. This is what's going to go for your turn. If you look inside that file, I think that's the next slide. Can you do this? Yeah, actually, let me go back.
Parent goes to sign the child's key, and the parent has a policy on how long its TTL is. We've got the child says something different. Is there a way for the parent to, other than manually inspecting the TTL instead, you can file a way for the parent on that and say, your TTL is too long?
Well, the parent shouldn't really care. Well, okay, I'm going to do
either one. If an organization has, for example, a policy that's directed from the top, and you want to ensure that policy is enforced, it would be nice if there were an option to have the policy enforcement within the thing times the ESET as opposed to by manual inspection.
Yeah, currently the KeySet program has no way of overriding the TTL or the validity. A future version will allow you to override the validity period, and will allow all the parent, the program that the parent uses to sign the KeySet to specify the validity period, which could be more restrictive than the one that the key is distributed or the KeySet has in it. Overriding the TTL is harder because the TTL is really more of the choice of what TTL to use is really more of a decision of the client than the parent, because it's the child's key, and it's being given out by the child, and if you have a TTL that's too large, you're not hurting anybody except yourself. I mean, I can't...
TTL, if it's too low, your name server will refuse to load that text.
What?
If the TTL on the key set There's less than the your salt minimum.
No, well, no, I don't think, there's no minimum that's gone though, so that doesn't really matter.
If you're concerned with what happens with the key when it's out there, with the key and the signatures, when they're out there floating around in DNS caches all over the world,
Right.
you're likely to set your TTL, you might have a policy that says you cannot set your TTL higher than this, based on the risk of how long that key material is going to be out there. Remember, we don't have a CRL, we don't have a repetition list. Yeah, the only limiting the TTL is one way to control how long a compromise can take.
True or false? In case of the parent control.
It's not really, because you can still, I mean, just because the TTL is low, the validity period is what's really important. If the TTL is low, someone can cache it, and someone can maliciously cache it for longer, for as long as they choose to, and as long as the validity period is still valid, it doesn't matter what the TTL is.
I think the point here is this context is a little different from what we're thinking of.
Right. I mean, I can see why, you definitely want to
If I build a higher assurance level that is generally implicit in DNSSec,
right.
one of my concerns, I have to worry about the validity period, granted, and I agree that somebody can maliciously cache it, but the number of people that are going to cache it, the longer the TTL is, the longer it can potentially be cached. Therefore, I want to be able to say, this is the longest you can set your TTL, and, you know, if I want the parent to be able to say, I won't sign that, your TTL is fine. It sounds like I need to do that in an external program, because the key signer does not have that functionality.
Yeah. The key signer does not do that right now.
I think that should be essentially the same thing as changing the validity period.
Well, it's a little bit different. The validity period is defined by the parent. The signature is by the parent, so the parent should be allowed to decide what validity it is signing for.
Yeah.
But the TTL is decided by the child.
Yeah, I'm not saying why the parents should care at all about the details of the
I think this is a case where you have a credit control up and down, you're trying to make sure that people low rank service below you are adhering to the right operational concept of your organization. No, we're not going operational yet, but we're not going to security companies.
I understand.
It's both up. My generic statement is, the longer the TTL is, the longer the key material is likely to be cached. Agreeing that you know, somebody's malicious can always cache it, and it's always been an issue as long as the validity period is. I guess one of the questions is, how are people here really expecting to do this operation? Maybe we're going to get to that later on, and I should talk about it at all.
Actually, we probably want to go very far of that. I guess, of course, this issue, a lot of people in this room think it's an issue. There's a lot of people in this room think it's an issue for that.
validity period, definitely.
Well, in the TTL, because we can talk about that afterwards, where that belongs in.
I guess what the basic question is, which one is normally going to be longer, validity period or TTL? I would say your would.
Yeah.
Much longer.
Yeah, it's also, if a recursive server gets a record, it will, if the TTL is longer than the lifetime of the validity period at that point, it will truncate the TTL to the lower fidelity.
Is that a healthy recursive server?
Yes.
Actually, there's one other angle to this issue too. If the parent doesn't sign exactly what the child gives it, the child doesn't really have a way to verify that the change is made correctly. We can talk about that later. One thing that's missing here is the child can send the parent something, the parent's signature to verify that. The parent sends back something which I've got to. The child can say, okay, here's what I sent, here's my signature over that. They go signatures again, so the parent comes back to me. And that ties it together. We don't have that tool yet. It's something we discovered. But if you do make changes to parents, then that won't work, and we have to figure out how to. I think this issue we can discuss that a little. Okay. What I want to point out here is after you've done making the key set. This is the key set here for one key. The key here is at the bottom of this picture, probably most of the keys. And that's the signature which is signed by the same key. And I'm going to give that type, whatever. This is the same key signed itself, the self-signed key. That self-signing key doesn't really mean a whole lot security-wise when I get to somebody who says, I have a private key for that public key. But what's important here is that the validity period is encoded here now, and also the TTL statement has been added. I here. This is the original, this is the keygen output down here. Shows the key mix is the same here and up there. Just rounded that way. And then I've added the signature, which has the blending period and TCL. That's out of that. So when you're looking at the output of the key set, you see this. Now, and they all have multiple keys in here to show you what happens. You have multiple keys in the file.
So, and Brian, what was the reason for having a self-signed stick in the set like this? I mean, why not just pass the validity period as a comment?
Well, there are a few reasons. The main reason is it's really easy to parse this format because it looks like a node file.
It's probably what makes you that.
Yeah, it didn't require writing any additional software because it just had load this thing that looks like a node file and parse through it. It also having a self-signed key record allows the key signer to attempt to verify the signature, which proves that if you create the key set file, you actually have the project key, which is possibly not that useful, but it's an extra little bit of authentication, which is good.
One thing to be aware, if you get this file and you verify this, that means when it sends you, that public key has a private key. But that doesn't guarantee that person owns the node.
Yeah, so it's not foolproof, but it's an extra step that the parents could do and make sure that someone's not just getting in a random file that they don't have keys for.
Only zoning is what Mark is talking about. I promise that he's not paying attention.
Okay, magic happens. The key set file I just made is going to become a .find key file because of what the parent does. And how that happens, I'm going to put off a little bit because I'm going to talk about what happens if you have to worry about using your own keys yourself. So if you have a parent sign, you can hit slide 28 and pick up from there. But one more thing about self-signing, and that comes up next, is if I don't have a parent signing my key, then I'm going to use that as my way of accepting my key. Okay, so what happens when parents are not secure, and I think I've graphed it before, I'm going to create a second key, which is going to be used to find my other key. The key that I use to find my zone is going to use a lot. I'm going to create a second key which will sign that key so people can trace through, like I had before with that one zigzag in the bottom of the top of the signed area. So in here I'm going to create a second key and make a key set, which you don't need to do. Again, I'm just creating a key, and basically this case here I do make a VSA key, not an RSA key. There's no reason to do one or the other. I just picked one and just made a change to show it. So I have a new key in my example, and I'm in key set, like I did before. So now, in this example here, I have two keys that was running here with plus 001, plus 003 on the RSA and DSA key. I'm going to create a set of that, and what will happen now is this will generate the same file as I had before, the same file name. One thing to watch out from there, you want to keep the key set file moving when you make the next key set, because they override each other, they do the same name. Okay, so I now have my key set, which has two keys down here, which I abbreviated in the slide, the key bit written there. And I have two signatures. Again, I've abbreviated the signature bits out. So now I have four records here. I have each of the keys plus a signature by each of the keys. If I have two keys, I have four records in there. If I have three keys, I have four. I'm going to sign with this key here, but I'm going to distribute this other key to all the resolvers. And because 5 307 signs 5, 8, 4, 8, 9, and the other also, I have a chance to trust. This is why, because all the keys I made in examples for this all start with a 5 in the footprint. It shouldn't happen. Or it's not likely to happen. Okay, slide 28. Whether or not I have my parent giving back key, signed key files, or I just in the last couple have my own key set file, I have to make sure I include that result in my signed file. This file usually here is the file generated by the signed zone run. So what you want to do here is, let's see, since we haven't done the validation yet within on 20, you only have your signed key. You can copy that into here now, but that's being able to check again when you go through the workshop. And you can bring up this file, look at your signed zones you put out there. What you're going to do, you really need to do is down here, we have those signed.
You don't need to do that.
You don't need to do that.
No.
Why not? Why not?
You never need it, because the signer will notice the signed key file and include it.
Assuming it's in the same record.
No, yeah. But you already need to have the files in the same directory for any children's business.
When I'm processing it. When I'm doing the planning of these here, but when I'm loading the name server right now.
Right. But when you're doing the
When you're doing, so you're saying the name server will automatically look out for a dot.
the signer will.
So the signer looks for something got signed.
Well, we're going to do
I'm not talking about that yet. I'm not talking about what you're talking about.
we said the cat assigned key file. Don't do that.
This is for loading it into a name server.
What?
What about a signed zone? We're going to keep that. Parent comes back with results.
Okay, the recommended usage is to rerun the signer at that point, or not run the signed zone in the first place, so you have to keep that back in the parent.
Well, I've heard recommended the other way that we should sign the zone.
The recommended usage is as described in the 5.9 reference manual, which is that.
You're talking before tweaking the other way.
No, I didn't. Other people did.
Yeah, other people did.
For those of us that didn't entirely follow that discussion, what I correct me if I'm wrong, what I think he said is, should be running use local dnssec-sign zone utility until you already have either A, decided that you're going to just have a self-signed zone, or B, got it signed by the parent.
Right.
And then the key file you specify should be what? Should be your key set file.
What do you mean the key file?
You specify the sign zone, where the keys are.
Those are the actual keys. So
Right.
it's just the name of the key file, the K whatever dot key.
And what modification, given that I got to work later that you say we're not supposed to, before we
There will be no difference. The only difference would be that if you had a .signed key file that you got back from the parent, the signer would incorporate that. And therefore your sign zone would have the parent signature of your zone key.
And how would that, what I'm concerned is what's medical incantation? Do I need to specify that .signed key file?
It will look in the file it will look in the directory for a file called your zone name .signed key, which is what the output of dnssec signed key.
If it doesn't find that, it just finds key set after that.
If it doesn't find that, it doesn't include a signature of the zone key.
So if you want to do a self-signed zone, you have to do what he's talking about there.
Or you can run dnssec signed key yourself and specify to sign your key set with the keys that are in it, and it will produce. It's basically the same file.
You can rename the file.
Yeah.
Okay, when I talk about sooner or later, it's a bit more what you're talking about, the swimming thing in certain places. But doing this or running the planner to combine it will give you the, what you want to load the name. So the reason why I didn't want to do the signer again is in case anything changes in your SOA number, once you do the serial number, I sometimes wonder whether I'm going to bump it up and start with. Originally, I actually didn't do the key processing first, then find the zone, but everything's going to depend on how you want to run your shop. Okay. That's very strong in both ways. Okay, what happens is when you've got your zones ready to go, if you make delegations now, you've got to handle the children that are delegated from you. This is a mirror of what the parent is doing for you and what he does once in a while. what your responsibility in terms of delegation says is, you delegate to a child zone something, and that child zone is not secure, for whatever that means. You have to insert what we call a null key. A null key is a key which can't be used for anything, and it signifies to dnssec that security stops here. So when you go to the child, you're not going to have any security record. So if your child is not running security and can't do it, you are required to have a null key in there. There's a small case where the child can hold their own null key, they can do it, but I don't think that's going to be a very large part of the population doing that. So when you have an unsecured child, you have to include the null key. If the child becomes secure, meaning that they've given you a key set file, you sign it to them, you take the null key out of your zone. So now that security doesn't stop here, it goes down to the child. So what happens is if the child is changed, your SOA number will change. The null key coming and going will change the zone. And that means you'll have to refine the zone itself and implement that. There are mechanics for this. Signing the key is how we're going to create the signed key file. But also the zone signer gets involved a little bit with this too. This shows signing a key for a delegation. The signing key is sent to. This is the name of the delegation I created, and I haven't done much before this with this delegation. And I'm using the private key here, everything's .private again, and I created a file. And what you see here, here's the key set and signed key file for that zone. If you can dip on that, the only thing that's happened here is the signature that came with that file is removed, and I added here the upper key, the parent signing authority. So the only difference between the signed key and the key set is the signed key has a parent signature over the key set, and not the children's key signature. This kind of summarizes this. What I was saying, I may not have tried on. I'll have to make it up.
Why would you want to keep the self-signing thing?
If you were distributing your own public key, you may want to have that in addition to one of your parents. For example, you have this weird network environment where you're disconnected from the internet, and everyone that's like you're on a ship or something, everyone you have is together. If you distribute your public key to everybody else, and also the root key. The root key we use when I'm connecting the internet. When I take off, I want to be able to use my key internally. So the self-sign there might say, if people want to find everything else, keep using everywhere else.
And the finality to deal with that? With self-signed keys?
Yeah.
It doesn't work in 9.0, and it might, it will work soon. It will definitely work in 9.1. I don't remember if it will work in 9.01 or not.
Okay. One thing I don't have a slide on is when you have your zone has delegations, and you go to sign it, the responsibility of the null key is decided by the signed dnssec signed zone. And what happens is you have a directory, you have your zone file in there, you have all of your keys in there. And what's assumed is that you are keeping around the files that were generated in signing the zone. Go back to. So in other words, I'm going to make sure that this file here, this file.dnssec and so on, all of my delegations, I have to keep the key set. What happens to the signer comes down through some data and finds a domain name in my zone, which is a delegation point. It looks into the directory and sees a file. That domain name got signed key. The signer will not insert a null key. If it does not see that file, it inserts a null key. So when you're working with delegations out of your area, and you may want to try delegations here if you have time. In the sign the code, you'll see that null keys will be added if you don't have the signed key stuff in there. Not the, it doesn't want the K subject file, it doesn't want the key set file, it wants the signed key file.
Your present with the file, what is it that actually could be?
And here, I think it's, Brian?
Yes, it is the presence of the file and the fact that the file actually has useful data in it.
Okay. So in other words, it assumes that when children are being signed for you, their signed key file remains behind in the direction that you signed your zone.
Does it deal well with 2 million that's
No, it doesn't. That's something that's been brought up before and will probably require a separate application because the normal user is not going to have to do with 2 million children, and it's really only registrars that have that problem. And it makes more sense to write a specialized tool for registrars than it does making a general tool more complicated so that it can be used by both.
Okay. Once you take all this work, you're ready to load your name server with the zone, figuring loading. What the server needs to get are the authority zones, which is what we give today. You need to give it now trusted keys from other parts of the internet, and in the ideal case, just a root key. And for our book up here, just a root key is enough. Shared secrets are going to be required also. This is a reference to TSIC that you should be playing with also. TSIC is the primary and secondary elements in the name. So this is why we probably have primary and secondary in the workshop. Okay, this is the slide on including the key. This is the dnssec result for the root key. That's not for our workshop, this is for another one. We take this output and we put it into the key file, into the navy.com file. Here, first key is the options for the part of the block. And in brackets we have in quotes the domain name if you want it to be .root. Take out the in and the key from this file here, and everything else goes down here, and the key actually goes into quotes. Now, one of the bugs we had before was that if the key file had white space or was broken over lines, we had a problem. I don't know if that was fixed or not, right?
Well, it hasn't been a release, so that's how we work with this.
I was reading it was 9.5 I mean, 9.5
Oh, okay.
No?
I don't remember that one. Okay.
Yeah. I'll do it this way. If it's not working, make sure it's all in one line for today, just to make sure it works. If this is a bug that's reported and has been done in code, well, not necessarily in the current release.
It'll be fixed at some point.
Yeah. I think.
Yeah, this looks like not.
In fact, one thing to watch out for in all is line keys are okay at the time. Let's throw that last one here too. Make sure it's all on one line. There are multiple keys listed.
Multiple lines.
This actually should be the same line. This is another mistake.
One entry,
Right.
line.
This should be all on the same line. I'm sorry about that. This should be there should be no new lines inside.
Yeah, you can have a new line between like the protocol and text string or basic keyboard string.
Okay, so this will work too.
Well, but that has a new line in the middle of the basic keyboard string.
Well, that was right.
That has been fixed.
Okay, and I know we changed the code. So just to make sure it's all in one line. And if you have other keys that you want to put in here, a doc is request from the domain name and the key is request from the if you don't do this, the validator will never kick in. So make sure this is done. And if you do this, and the validator does not kick in at all, you didn't do it right. Okay, to do the zone trash protection, do TSIC. The first thing you need to do is come up with an HMAC MD5 shared secret. And you can do this, you can probably do this right now. This is the command to do that. The whole thing, the whole line. What's in red is useless information that has to be passed. And I pointed out because you have to put something in there for it to run, but it doesn't matter what you call it, necessarily. minus A, HVAC MD5, minus B, it's on the secret side, and you'll have to if you put it, you have to put in a name type, but it doesn't make a difference to this. And whatever name you steer is somewhat arbitrary. I'll talk about that in the next slide. You need to have something, and the only thing I have right now is that's the name of the file we put on it. Now, what's going to come out of here are these are the two files. This is the, let's see, this is the .key file, it's the one-line output, the same as it is for every other key. This is the private key. The private key for the other key algorithms are more involved. There's a lot more numbers in there. But what you see in both of these, they both have the same shared signature I have in red here. That's the shared signature that's going to come up. It should be the same. You're going to need this when you go to put that anywhere else. That shared signature is what you're going to be doing with the team. Okay, the name that you use, I have to leave it here. The name that you use has to be unique for the two name servers involved, because they will pass the same back and forth just between the two of them. So everyone can have, if we had key 1 and key 2, and this thing traditionally that would work. Key 1 with the person on one side, you key 2 for the other, and alternating that would work. You don't, it's kind of messy. One recommendation is to use some combination of the zone names that are involved in this transfer. What you do want to do is you do want to keep it somewhat short because it is transmitted. But you want it to be unique enough between the two name servers. And right now, I don't know if any really good guidance to say this is the best way to do it in general. But now, talk to somebody else who's doing secondary, talk about what you want to call it. Going back and forth. And the name of this is not secret, but the key is on it. So when you make this key up, when you make the key up right now, be aware that you're going to have to use that same, someone else wants to use that same name. Right when we do all these key-state primary secondary transfers. So you may want to change the name, you can do that just by changing the name of the file. Actually, that's changing the name of the file. Okay, this shows how this impacts the configuration file. I have a primary server here, this is on .12. This is .9, the secondary server. In here, they both have the same key defined, both zone dnssec sec 1. And the secret here is the same on both sides. These set of statements are the same. In other words, you're going to have a statement with your one neighbor and set statement with the other neighbor in your file. Have it named one of your neighbors. Down here, though, I have information about the servers. This down here says that when you talk to the server, IP number, always use these keys in doing the query response security. So I know that if I do a T-state on these, all my notifies, or my requests, or my answer queries, and so on, signed by the key here, or key hash here, key hash right here. The primary is going to specify the secondary by number, the secondary specifies the primary by number. So they cross. And again, you're going to actually have a pair of this for the one for secondary, and another one for the one for secondary for you. Here is the file. Okay, does any of this work? This has been a big question in a lot of workshops. How do we know this works? One of the catches here is discovering whether things are work or not is that whenever you do a query to somebody else, if you get back an answer, you'll never get back a bad answer. We have this thing called AD bit, which is supposed to mean that yes, this is a good answer. There's a catch in the spec that says that AD is not a good answer. For the most part, it's not returned. There's an exception. Like if you tell the server, don't do checking, maybe it may not be turned on, but the server didn't check it. Why? Normal situation, everything will come back to the AD bit turned on. It'll never see it turned off. And the reason why this is not completely satisfactory right now is that you could have an answer coming from an unsecured part of the tree. In other words, anything that comes from the .com now, .com, that's not secured. So when you get the answer back, your validator say, well, even though I have this root key here, and I see down that the .com has a null key, so there's nothing out there. That answer is secure, because there is no security. Nothing went wrong validating. There's also answers that come from secure sources, and a validation check has occurred. So in that case, I'm sure it came from the right place. But as far as the spec says, the two of the answers are equal, because you can't expect everyone to be secure. This is why the volume is important at this point in the workshop. To see whether or not they're getting the validated thinking and do the work. The validator will say, I see an answer, I validated it, and we just yes or no. So the validator is going to be doing all the logic output that you see, and you really want to be thinking in for. How the value is kicked in is described here. Validator is invoked whenever the answer comes from something underneath the trusted key area. Root key is there, everything will be somehow checked. If there's no root key, and I have other keys, I look in those areas only. How do I judge whether that the answer should be secure or not? I go to the closest key. If you look at a tree now, imagine when you're in a tree. If you have more than one key, you're going to see box marks through there. One key will be closest to you. I start from there and go down to see if I'm still in a secure area. So even if the root key is there, and I have another department key here, and so on, that answer is going to be considered secure from the department key, not from the root key. Now, in checking validation, just going to log output here. If a validator does get an answer from an area that's supposed to be secure and it fails to check, you'll see third fail come back in your answer. That's a sign that you're dropping the data. One thing to be careful there is the third fail there only security failure. It could be whatever third fail was meant to be originally. That's not a guarantee that the security failed, but it is a sign that something failed. Watch out for these two things I have here. If the system clock is not right on time, you may be getting the signature out of date. We saw cases where people in Sweden had signed the zone with a key on one machine, but the signature didn't take effect until 10 minutes before someone who clock was lagging.
So their clock is up.
Either way.
Their clock was in compliance. So we have to get data up.
In particular cases, there were some way off clocks. I haven't seen a machine to believe it was in kept it in 98.
We have an NCT server here, so that shouldn't be an issue.
It should be. So I recommend NCT your security key, eventually. You want to have that running.
Address 1.
There's two things in the trusted key. That's probably more. And music is always going to be seen as on when you use the normal gig. Okay, and down to the last couple of slides here. This next couple of slides are going to have a lot more detail than I really want to spend on right now because I haven't gotten it set up yet. But to give you an idea of what happens when you try to design the zone, I found if you design on Monday as it comes around, to remind yourself. It should be taken the wrong way by a few people. You never know what happens to you on Monday. The sign file that we process can be used as input for the next signing run. I've talked about that a few times with the cycle and so on. You can take the sign file, increment the SOA number, make changes, and then run the sign back as the next file through there. This allows me to recycle signatures that are still good. One thing that just popped up recently in the zone by design, it used to be that would then resign all of your keys and keep them current. The problem is that the keys don't get updated by the signer the same way. The keys have to be signed by the key signer. So every time you sign the sign, you may have to go off and see if the key has to expire, make a new key set, even if I use the same key. Make a new key set and find the key for them to be included. This is an example of how I might go through this. I have, actually this is an example Up here, I can make a copy of NANOG 20.signed and make that NANOG 20.2010.2501. And edit that, make changes. If the sign goes here, I'm signing NANOG 20. And this is the file that I'm reading for that, for the update. And down there is the key that I'm using. If you want to update the NANOG 20 key signature by root, if you make key set again, that's the key jump. Okay, changing keys is where quite a bit of work comes to come. Keys have to be changed every time because they go bad. For some reason, one doesn't go bad. You may want to change your key, meaning that I actually have to compare if this set of keys now validated. The parent may change their key, which means that the validation I had of my key is no longer very good. I have to go back to the parent saying, give me a new signature. And the children you have may change their keys, and I'm going to cover that in the slide. That's pretty from your definition of what's happening in your parent. Okay, yeah, I'm just going to lay these slides out here for later. This is how you go about changing your key. And what's important here is that you don't key 1 to key 2 suddenly. You want to have key 1 and key 2 overlap, so there's a progression of security between keys. You don't want to think of that disruptive. It talks about doing that in states where key 1 and key 1 and key 2 overlap, then key 2 continues on. When the parent does a rollover, when they try this here, what the parent has a new key, or doesn't know about one of your keys necessarily, what are they going to do? Are they going to put null keys for everybody who's re-signed keys in the period? We don't know yet. Okay. One thing that made here that because this is a spec that's developing and software is developing. We know that this is not going to be the easiest thing to use, not the most quick for the software out there, not only issues that are possible. But we do know that things are going to be needed. And that's what we want, that's what we're trying to learn in the workshop is what do people see as missing pieces. Debugging configuration looks like a lot of experience, so you're frustrated with something, don't be afraid to ask. GDB sometimes is used to figure out why something wasn't accepted, which is very clumsy to do, but right now we have to do that. And managing rollover, which we're talking about what I just mentioned, we do need more tools there. We have some things written about that that hasn't gotten very far yet. And ideas for working in this area are always welcome. And I do want to mention that there are a few things that we know are changing. 591 is already being written as we speak, and there are changes coming in that. And some of them I haven't here, but for today we're dealing with 9.0.0. So what I have applied here applies to that. But change 9.1, they may change. I think everything I said here will stay in 9.1. They'll try to be minimal change as possible, but things may change. Keep in mind we slide for 9.0 for today. And finally, there we go. Now you should have some of the PowerPoint report now. Are there any questions? Any other questions?
Yes. I have, your last slide was slide 9.1, recognizing that NAI doesn't necessarily control all of what happens in line releases. I don't know if there's any line here.
Right here.
Brian is certainly
Well, no.
There's the reason why machine Benedict named Benedict. Our ex-employee.
What I hear, let's go ahead the question is, there's 9.0, which is out the door, there's 10.1, 9.1.
I believe the plan is that 9. Okay, this is all what I heard yesterday. I don't know how accurate this is. I just did the office of the week. 9.01 should enter beta very soon, like within the next few days, and should probably be released about a week later. But you don't expect there to be too many bugs in 9.01 because it's basically just bug fixes from 9.0. 9.1 should enter beta in about 3 weeks or so. It said sometime in early November. And the plan is to have a release by the end of the year.
To carry on to that, and again, putting you on the spot for stuff you can't necessarily be authoritative for. Getting by 9.1 to run on older versions of Solaris and HP. One of the customers that came for a lot of the By 9 development is still running a lot of Solaris 251, HP
problem with it. That'll be addressed, Rick. Yeah,
when is it going to be addressed? Today, or in a follow-up message? I mean, this question's been asked repeatedly, and nobody's addressed it to the satisfaction of my customer, as far as I know.
Well, we probably better talk.
Okay.
Yeah.
Okay. The related question then, of course, is also By 9 for NC. There's been random emails floating around that said somebody was actively working on putting By 9 NC, but I don't know how official that is.
the only message I've seen about that didn't look very promising because it looked like they were planning on doing it really badly.
They are going to work with NC.
Well, that's true. It's hard to do anything well, and there are different degrees of that.
Okay. As for having Microsoft servers secondaries, the server that handles this 2K is not going to work well. The one that handles the next software house should work.
Microsoft is a pretty good asset.
They support the records.
Well, it's not the recording key records, right?
No, they won't.
Still won't work. Okay. And they're not going to return SIG records.
They'll return the records if you ask for them.
Which is the software.
Yes.
So what is that to work? Okay.
Related question to that, NT4 DNS server, the last time I went through a cycle of testing to try to do compatibility, you need an NT4 system, a secondary for a time zone, and through all these records you couldn't understand out before.
Yep.
And if you made it to be recursive, you then had it get records in the time zone, it sometimes fails, sometimes passed on CCA records. Okay. Is anyone working on By 9 doing any kind of interoperability with that with NT4, or is it my problem?
I don't think there's really anything we can do about that. I mean, there's no way to determine that a query came from an NT4 server and return different data depending on that. It's really just no way to do that. You have the same problem with any server.
I understand that. It's in the category of the By 9 release notes don't say anything about things that I think are problems.
Yeah,
And I mean, before the By 9 can do anything about it, it might be nice to tell people, if you start finding zones, I know you have a bunch of NT versus servers, they're all going to break.
I don't think it's By 9, I think if you run a Windows 2000 server and put in record types that aren't understood by an NT4 server, you're going to have the same problem. It's whenever you have any record types that are not supported by, and if you have a recursive server that gets really confused by unknown types, and if you have anything with an unknown type, you're going to have problems. I don't think it's By 9 specifically. I just think it's the fact that By 9 supports newer record types.
Okay.
Just because you're using By 9 doesn't mean you have to use newer record types.
We're going to take a 2-minute bio break if anybody needs, and then Mark is going to go through the key signing procedure.
Basically, the signer needs to be able to and without
somehow people do figure out, what or you have to then centralize all of these files. I'm going to get children that are look at this file, this file, this, so what it does is this, you look for zoning by which is what the output is.